So this should be the last video on partial fraction decomposition. We've done the case where we had linear factors that weren't repeated, linear factors that were repeated, irreducible quadratic factors that were not repeated, and then the last one was some quadratic factors that were repeated. So this is more like a summary of all the different cases. So the problem here is to set up the partial fraction decomposition. We don't want to solve it. Well, I don't want you to solve it. It'll take a while to do it. So it's just to set up. You want to pause the video and try it, and then I'll be right back. Okay, so let's look at this. It is in proper form. The degree of the numerator is obviously smaller than the degree of the denominator. In most of these, at least in the numerator, that's not going to factor in over real numbers. It will factor over complex numbers, but we're not looking at complex numbers here. So what we want to do is make sure we have everything factored out in the denominator over the real numbers. So for this one here, this trinomial first factor here, we can take out an x. And then we're going to have left an x squared minus 4x. And then the trinomial x squared minus 4x plus 4 does factor into x minus 2, x minus 2, or x minus 2 quantity squared. So let's look at this. The x then is a first degree factor, linear factor. There's only one factor there of x, so it's not repeated. X minus 2 is a linear factor, has an exponent of 2, so that is repeated. So these two cover the first two cases that we have. And then the next one is a irreducible quadratic, doesn't factor over the real numbers. Now you can factor it over imaginary numbers or complex numbers, but we're not looking at that right now. So that one's going to stay the way it is. So this covers the case where we have an irreducible quadratic factor that is non-repeated. And then the last factor, x squared plus 5, that's to the third power. Another irreducible quadratic. This one is repeated. To the third power. So this covers all the different cases that we've had. Linear factors that are not repeated, linear factors that are repeated, irreducible quadratics, factors that are not repeated, and the case where we do have repetition. So remember, when you have linear factors, it's a constant over the factor. So this would be, say, some constant a over x, another constant b over x minus 2, another constant c over x minus 2 squared. And then remember, for the irreducible quadratics, the numerator will have something of the form ax plus b. And then it repeats. So this is your setup here. And then this is what you have. I have it written out, typed out, so you can see it more clearly. Got x squared plus x plus 2 in the numerator. And then here's the factors form of this. And this is what we're going to have. Now you can use just A, B, C, D, E, F, G, as many of the letters in the alphabet that you need. But here it's convenient to just have a subscript. So A1, of course, will be different from A2, which is different from A3, and so on. So the setup will look like this. So one constant over x. X minus 2 was to the second power, that's repeated. So we have one constant over x minus 2, another constant over x minus 2 squared. If that had been cubed, then we'd have another constant over x minus 2 cubed, and so on. And then we get to the irreducible quadratic factor, x squared plus 2. It's not repeated. But again, the degree of the denominator for this one is 2, so we expect that the numerator would be degree 1 less than that. So it could be degree 1, have an x on top, or it could be constant if a4 is 0. So that's the way we have it. And then we go to the next one. This one is repeated 3 times, so we're going to have that many factors. So x squared plus 5 to the first power, and then the constants a sub 2x plus a 7x. Then a square, same setup, a sub 8x plus a sub 9, and then the final one to the third power, a 10x plus a 11, and that's your setup. Now, if you were asked to solve this, say in a test, that'll be quite a problem. It's not a hard problem, but it's going to be tedious. Now, if you wanted to solve this, well, you do it just like we did the other ones. We multiplied both sides of this by the LCD, which of course would be x minus 2, x squared by 2 plus 2, x squared plus 5 to the third power, and set up your system of equations. Remember, you can just shortcut methods that we went through where you could substitute values. Like in the last problem, I believe a lot of the constants went to 0. It worked out nice. I don't really know what this would do, but anyway, that's the solution to this problem. Thanks for watching.